Hello and welcome to Coffee and Games, or Games 101, or Unity 101, or whatever you want to call it. Anyway, today we're going to be building a really simple, classic variation on the apple picker game, or the Kaboom game. You may have seen, the typical something moves across the top of the screen, drops something down, and the player has to either catch it or dodge it or something like that. In our case, it has to catch it. So the classic is the apple picker, and you have an apple tree that drops apples. But the art I happen to have is cherries, so we're going to do a cherry tree. And this is the goal, because it'll wind up something like this. Okay, so at the top we have our tree, and it is dropping cherries. It's dropping them awfully fast in this version, but we're not going to actually have our version. And if I miss, I lose baskets, and eventually, you'll notice there's a high score. Yeah. Eventually, if I lose all three of my baskets, the game restarts. Okay, that's the basic idea. We're going to try to do this entirely from scratch. So this is going to be a 2D version of the game. The 3D version of the game, well, if you were just using 3D assets or you're just using a tree that moved back and forth that was 3D, it really wouldn't be an awful lot different. But in this case, we're going to just do it 2D, and we're going to call it New Cherry Tree. That sounds good. We're going to call it 2D, and we're not going to add any assets. We're just going to go ahead and create that project. All right. Now, a little ahead of time, what I'm going to do, I have actually pulled a few assets. I've collected some things from the web and from the asset store to kind of make life a little bit easier, because I'm not going to get into actually creating the images or the sounds. We're going to use some that I found on the internet. The cherry tree itself and the little basket platform thing, and so the cherry tree, the cherries, and the platform I got from the Sunnyland package at the Unity asset store. So you can go over there and grab that. And the sounds I just kind of grabbed off the internet, and I think I made the splat sound myself. But anyway, that you can use any sounds for that. So our game is going to have some pre-made assets and some pre-made sounds. So here they are. There is cherry1.png, and let's put that into our assets. There is platform long. Put that into our assets down here. And there is tree.png. We'll put that down there too. Now there's the glass ping. It's a sound we're going to use. Pew pew is another sound we're going to use. And splat is a sound we're going to use. You could also have background sounds, if you wanted to have background music and things like that. But you'll get the idea from here. All right. So we're starting off. We're going to use the standard camera setup. We have a solid color background. It is an orthographic camera. I'm not going to change any of these things. The important thing in a 2D game, most of the time you're going to be using an orthographic camera, meaning there's no perspective on it. There's no camera parameters. It really just gives you exactly what you see on the screen there. So let's add our first element. And of course, I think the most important thing to add is going to be our tree. So let's put a tree into our scene. And I'm going to double click on the camera. Going to show me where I am, and here's a little preview of the game. We now have a camera, we have a camera and we have a tree. Let's make the tree a little bit bigger though, shall we? We're going to scale the tree up, and I'm going to make it 2 by 2. 2 by 2. That's a reasonably good size, and we're going to move it up on the screen a bit. So maybe 5, too high, 4, 3, perfect. All right, so we've placed our tree on the screen. There it is. It's a tree. We hit play. What happens? Nothing happens because the tree has no behaviors. It really can't do much of anything. So let's start using some scripting to make the tree move. How do we do that? We go over to tree. We look at the inspector. We're going to add a component, and the component we're going to add is our tree script, new script. We'll call it tree. This could be cherry tree, it could be apple tree, it could be whatever. We're just going to call it tree. Now I double click on that, and I'm going to get Visual Studio, and I get my standard mono behavior for my tree class and my tree script here. I get a start and an update. I'm not going to worry about that too much, the start yet. But the first thing I want to do is I want to make my tree move. And that seems like a good thing. So let's see. We'll give it a speed. So the first thing we'll do is we will say public float speed. And we'll call this tree speed, so that we know we can differentiate it between apple drop speed or whatever. And we'll say this is going to be, I don't know, let's try 2.0, and it's a float. There it is. We've declared our first attribute of our class here, our first variable within the class. Now we're going to use update to move that. So the simplest way to do that is we're going to use the transform of our game object. That's something we can grab. Hopefully you've learned a little bit about transform. That's basically the position, the translation, the kind of the basic where the object, the game object, is on the screen. So transform dot translate. We're going to move it. I like to use the translate function for moving. So what it does is basically whatever the object is in terms of its coordinate, its world space, its orientation, it's going to move X, Y, Z up, across, up and down, and so on. In this case, we're going to just move back and forth or horizontally. So I'm only going to use X. So I take speed, tree speed. That's better. The IntelliSense or IntelliCompletion took care of that for me. That's good. And I'm going to scale it according to the amount of time that's passed. So time.delta time. And the other Y and Z are just going to be 0. All right, so now what should happen? I'm going to save that script, come back over here, and press play. So if everything went okay, you'll see that the tree now starts moving across the screen. And it keeps moving across the screen, and it keeps moving across the screen until it goes away, which is not too great. So one of the things you might want to do is you might say, well, okay, once this tree moves a certain distance, maybe I should change the direction. And that is something I might do. We'll go over to the script again. We'll say tree, and we'll say, basically, if you want to change direction now, if transform dot position dot x is greater than, I don't know what, so we'll say 5.0f. We're going to say tree speed change direction. And the way we change direction is times equals -1. Right? So it moves the tree, changes its speed to the opposite direction. Now, you'll notice this is complaining up here. Why is that? Because I didn't put a parentheses. All right, fix that. Transform.position x greater than 5, then tree speed in that direction. Save it. All right, let's see what happens. All right, moving along, gets to 5, changes direction. Great, perfect, we're all set, right? Oh, wait, no. It went off the screen in the other direction. That's not great either, is it? All right, so we could put another if in there. Just say if transform.position.x is less than -5, then move it the other thing. Or we could do something, I think, a little more clever. We know that the magnitude, we're centered at 0, so the magnitude is going to be 5 in one direction and 5 in the other direction. So instead of having 2 comparisons, we're going to use a math function. We're going to say math f.abs. And why isn't it doing the right autocomplete for me here? Let's see. Math F, let's see. What did I do wrong? I probably just didn't, yeah. I didn't get quite the capitalization right. Abs of that X. If that's greater than 5, tree speed, okay, that seems like that would be pretty good. Now let's see what happens. Okay, we hit play. Our tree will move 5 in one direction. And, excuse me, we'll have some coffee. And 5 in the other direction. And then bounce. Now that's cool. All right, that's better. The problem is that that's not really the screen size, and it's sort of an arbitrary number. I could change that, but instead I want to introduce you to something. I want to introduce you to physics and collisions and kind of the proper or fun way to do this. Like imagine you had a game player and it was moving around and bouncing and that sort of stuff. And you want to bounce off objects. You don't want to like hard code everything in there. So instead of comparing to a specific number, I'm going to add another object in here. I'm going to just put a empty object in for now, and I'm going to call it, boundaries. So let's call it boundaries. Okay. Or even we'll just call it bounds, just to be more concise. Now, the thing I'm going to do is I'm going to use a physics 2D object. I'm going to create a edge collider. So an edge collider, that gives me something that I can bump into, that I can collide with, and change stuff as it goes along. Okay, so first thing I'm going to do is I'm going to take my boundary object and I'm going to move it. I'm going to locate it down at the very bottom of my camera screen here. So I move that down there. So that's at -5. And now let's edit that collider. Let's give it some edges here. So we're going to come up over here to the top, and we're going to put this over up the top there. You're asking, well, why are you moving it to the top? Well, you'll see in just a second. I'm going to pull out something right there, put that at the bottom, and I'm going to pull that one out and put that at the bottom. I'm not concerned about the top of the screen just yet. And in fact, in this game, there's not much going on at the top of the screen. So I'm really just going to have the two sides and the bottom. Okay, that's now my edge collider. So in order for an edge collider to work, I have to have some physics on there as well, on at least one of the objects. So we're going to come back to the tree, and the tree also needs to have a collider in there. So I'm going to add a component. I'm going to add a physics 2D box collider on the tree. That makes sense. So now I've got an edge collider and a box collider. And what happens if I hit play? Well, nothing. I'm not going to bother hitting that yet because of my script over here, the tree's never going to get to bounce into that. So what I'm going to do is I'm going to eliminate this if condition for now. Just comment that out. Okay, save that. And now let's see what happens. No guarantees here. I'm just kind of like, adding stuff and seeing what happens as they go. So boom, it hits it and nothing happens. Of course not. Why? Well, we have colliders, but no collisions are really happening because there's no rigid body 2Ds on anything just yet. We have to put some more physics to it. All right. So on the tree, I'm going to add a component, and the component I'm going to add is a physics 2D rigid body. Physics body rigid 2D. There we go. All right. Now, I'm going to put some constraints on this as well, because what I'm going to do is I'm going to take responsibility for moving this object around. And I don't want it interacting with objects for physics. So I'm just going to, turn all these things down here. It's going to complain and say, well, why are you using this thing? But anyway, now let's see what happens. It's going to move across, and well, since I'm in control of the physics of it, my collision isn't going to be doing anything. So that's not great. I need to have some way for this collision to really happen and something to trigger. So let's go back to the tree again and say, well, let's give the script a behavior that will cause that collision and cause this condition to happen. So let's do this. Let's create a on collision enter function. So we'll say private, and that's really kind of optional, I guess, void on collision, not exit, but enter 2D. Okay, whoops. And it's important to get the capitalization right because this is C# after all. Okay, so on collision enter 2D, and I get past a collision 2D object, so it's going to tell me what I collided with. And now what I'm going to do is going to say, okay, if the tree collided with something, we're going to change direction. So let's save that. Let's see if that worked. And hit play. And there it goes. And boom. Okay. now we've got something going on. So every time it collides with that boundary, the tree changes direction. All right, we're on a roll here. So we no longer need this. We have the tree translating back and forth because it's bouncing into things. Now, just to set this up for later, I want to be careful because it's the tree colliding with the edge or the bounds that's really causing this. So I want to be careful and make sure that that's what I'm reacting to. So I'm going to say collision.gameObject. This is going to tell me what it is I collided with. Okay, so if the game object I collided with, if its name is equal to bounds, right? That's what we named that object. Then we'll change that direction. Okay, so now only if we bump into the bounds will we change direction. Let's make sure that works again. Have a sip of coffee. Okay, ready? Bounce. Okay, we're still working. That's great. So far, so good. So we have our tree moving back and forth. What's the next thing we want to have happen? How about we drop some cherries? Right? Okay. Now, so to make the cherry, we're going to come back over to our assets, and we're going to take cherry 1 and drag that into the scene. And now we get a cherry. And the cherry is really, really small, so let's scale the cherry to be 2 as well. And there's a cherry. Okay. So if I hit play, it's a cherry. Not much of anything. So let's see. I want the cherry to drop. Now I could programmatically go in and make it do that, or the proper thing is to go, of course, add a physics 2D rigid body and make it capable of dropping. So I will just use all this normal stuff. It has gravity now. It has mass. It is simulated, and let's see what happens. Okay, so hit play. It has a rigid body. It drops. That's great. Well, okay, it just dropped forever, which isn't all that great. And it just dropped from there, which isn't all that great either. Okay. Well, we need to start managing our cherries there, right? So let's see. The cherry, we're going to have multiple cherries. Pardon, I'm flipping through some stuff on my desk here. The cherries, we're going to need lots of them. So whenever you need lots of something, generally what you want to use is a prefab. So to create a prefab, we're going to grab that cherry, we're going to drag it back into our assets. And the moment we do, you're going to see that we have assets cherry 1 prefab. And that is now the more interesting thing to use. So we're going to go over here. We're going to delete that cherry. Whoops, can't do that. I delete that. Okay. So we have created this cherry prefab. And we can open the prefab and we see it's got everything we just made. So what do we do with it now? Let's go back to our scene. We say, well, where do cherries come from? Cherries come from a tree, right? So let's go to our cherry script and say a tree can drop cherries. All right. So here's our tree script. And we need to drop cherries. So let's create a behavior called drop cherry. And that will be a void function. And we will call it drop cherry. All right. So how do we drop a cherry? Well, we're going to need to create that game object, or create multiple of that game object. So we'll say game object cherry equals, and now here's the fancy part. We're going to instantiate a game object. So instantiate, game object. And we want it to be a certain type. We want it to be the cherry prefab. So how, let's see, we'll just call it cherry prefab here. And where is that going to come from? Well, we need to know. This is obviously not defined right now. So we'll come up here, we'll create a public game object, cherry prefab. And this, now we can reference that. Now to get that to our script, we need to use our interface over here. We'll come back to, whoops, tree, see it in the inspector. And now if we look in our script, you'll see it's waiting for this cherry prefab over here. So we'll come back here, we'll say cherry, drag to our prefab, boom. And now watch what happens. Nothing. Because we have a drop cherry function, but we're never calling it. All right. So let's switch back over. Visual Studio, and let's tell it the first thing that we do is we want to drop a cherry. Okay, and that's great, but how is this going to work? Let's see. First, we're going to drop a cherry, and then we want to drop more cherries. So every time you drop a cherry, you'll schedule dropping the next cherry, right? That seems like a good thing. So every cherry will, once it drops, it's going to know about the next one. How do you do that? You say invoke drop cherry. And we're going to tell it to wait a certain amount of time. We're going to wait 1 second to drop, to drop the next cherry. And maybe what we'll even do is we'll wait when we first go here. We're going to wait 2 seconds before dropping the first cherry. So start will happen, we'll wait 2 seconds, drop the first cherry, and then after the first cherry drops, schedule another cherry to drop every second after that. So let's see that happen. All right, so 2 seconds, a cherry drops, and another cherry drops, and another cherry drops, and we see all these cherry clones happening, and they never go away, and we need to do more work. Okay, let's go back to our script, shall we? So we need to think about what happens to cherries. What happens to cherries? Now, first off, we don't want them dropping from just the middle of space out there. That's not great. So why don't we do this? Our new cherries, as we create them, we will move them. We're going to say cherry transform dot position equals, and where we want them to start from? We want them to start from the tree. So we're just going to use transform dot position of the tree. Okay, so the cherries will drop starting at the tree. And let's see what that looks like. One step at a time here. All right. Okay, cherries are dropping from the tree now. That's great. But we are just creating infinite cherries. That's not too great. All right, now what? Okay, we have the cherry, we have the tree, we have bounds. Now, I like to put as much functionality in the actual scene, maybe a little bit less in the prefab. So this bounds thing here, the cherries, I want them to go away when they hit the floor, when they hit the ground, they hit the boundary there, right? So, just like the tree had a behavior, I'm going to add a behavior to the ground. I'm going to add a script to the ground because it already has an edge collider. Say add component, new script, and we'll call this bounds. All right. And this is a little bit dangerous here, naming everything bounds in there. But we'll see. And you know, if you experience any weirdness, you might want to be careful about that. So anyway, all right. So we have the boundary, and we are going to now say what happens on collision with the boundary. So we'll say void on collision. Whoops, on collision. And why am I not getting my bounds.cs? See, this is the first indication that something a little bit weird is going on, because now suddenly my autocomplete things aren't quite happy here. So let's do some different things. Let's delete this script. Remove that component. We're going to add a new script called, what do we call it? Boundary behavior. Create and add. Okay. So now let's double click on that. All right, boundary behavior, get rid of this one. And we'll remove that. Delete. Delete. Now, everything looks a little happier now. Don't save. All right. Yeah, sometimes that's one of these good indicators for you. Like if something's going wrong, suddenly you'll see weird behavior. So that's something to keep around or keep your eye out for. So on collision, enter 2D. Okay. And what do we want to do? We want to say if the cherry drops, we want to destroy a cherry. So anything that hits the ground, we want to destroy. Okay. Destroy collision dot game object. All right, perfect. So anything that hits the ground, anything that hits the boundary, destroy. Wait a minute. No. The tree is hitting the boundary. What happens then? Let's save that and see what happens. So the tree drops cherries. They get destroyed. Wait, they didn't even get destroyed. And the tree got destroyed. That's not great. Okay, so let's see. Let's go to the bounds again. Go to boundary behavior. And we need some way of telling whether or not cherries hit the ground. Now, one way you can do that is you can look at that game object. You want to say, okay, if collision dot game object dot, and we're going to use the tag on there. If it's tagged cherry, you can destroy it. Okay? But otherwise, don't destroy the tree. Only destroy the cherry. That sounds like a better thing. Okay, so the bounds has an edge collider. The tree has a collider. And again, let's see. But now let's see. We drop. And the cherries are not being destroyed. Why not? Let's see. The cherry prefab, I'm going to open that up. It has a rigid body 2D. Oh, it doesn't have a collider on it. So, let's add a collider. Physics 2D, box collider, or maybe not a box collider. Maybe we want another type of collider. Remove that. We'll say add component, physics 2D, circle collider. That's cool. And if we want to edit that circle collider, we can do that. We can move it around a little bit. Don't want to actually move that. But anyway, that's pretty good. So we like our cherry circle collider. And now let's hit play. And since we have a collider, and we're going to drop some... Oh! Well, they hit there. But they didn't destroy. Why is that? Well, we haven't tagged them yet. Stupid me. Okay, here's our transform. How do we set up a tag? Up here, we want to say add a tag. Add to the list. Cherry. Cherry? No. Cherry. Save. Let's go back to cherry 1, tag it as cherry. Now hit play. Dropping cherries and they're disappearing. Awesome. Okay, we drop cherries, they disappear. Whew. We're halfway there. Now, so what else do we need? What else do we need? We need a basket. We need multiple baskets. All right, so let's look into creating a basket. Now we use the platform for that. We're gonna bring it over here. Now we have a platform in the scene. We're gonna scale it by 2, just like, whoa, not 22, by 2, just like we did the other ones. But maybe we want to create X a little bit more, 2.5. Okay. So we have a basket in the scene now. And the basket we want to move according to how the mouse moves. So that is a little bit trickier than just physics moving. So we're going to need a script for that. So we're going to call this not platform long anymore. We're going to call it basket. Okay. And we will create a script, a new script called basket behavior. Okay. Create an add. And what do we want to do? So in our update routine, that's where we usually do a lot of our movement. So here, what we want to do, what happened here? Basket behavior, basket behavior. I always get nervous the moment I start seeing things not defined. What did I do wrong? Maybe it's not saved yet. Let's do this. Let's close that. Double click on that. New cherry tree solution is already open. All right, I don't care about that. Well, let's move ahead here. Vector 3. No. Vector 3. Raw mouse equals, so I'm going to grab the raw mouse value, input dot mouse position. Okay, that's going to grab the mouse position at any particular time. Now, what I'm going to do, let's close this down, and I'm grabbing the mouse position. I'm not going to be able to see anything because that didn't happen. So let's see. I still don't like the fact that basket behavior is acting weird like that. All right, let me close that. Well, let's move ahead. Input mouse position. And then to convert that, we're going to need another vector 3. We're going to call it converted mouse. And that is going to be, we're going to convert it according to the camera.main dot, and here's the magic, screen to world point. I'm going to pass that the raw mouse position. Okay. What that does is it converts a raw screen position to a point in the world. And that's what we can use in our, for our game object. So we'll create one more vector 3. Vector 3. And we're going to call this just pause. And we're going to grab the current position of the object that we're dealing with here, which is the basket. Transform dot position. And we are going to say that pause dot x. I'm going to overwrite the x with the converted mouse position. Dot x And then we were going to write that back. Transform dot position equals pause. All right, so if all goes well, I'm going to close that. All goes well, my platform will follow my mouse now, which it does. Okay. And it has no interaction with the cherries, though, but at least it's moving back and forth.